This week, we're celebrating 4 years of AG3D, and we almost had the house burned down, but it didn't because of things like redundancies. We'll see how that relates to the space industry. We're talking space shuttle, we're talking Falcon 9, and we're answering your questions from last week's episode. Welcome, everybody, to Today in Space. It's a pleasure to have you here. Thank you for joining us. I am Alex Orfanos, your space podcast host from the East Coast. Thanks for coming. Thanks for joining us. I hope you had a good Thanksgiving this past week. I know it was definitely different. I mean, definitely a lot smaller for us here. Definitely makes things a little weird for a holiday, but I hope you stayed safe and you were well out there. This week, I have a few thoughts that I wanted to share. You know, I'm still catching up from the holidays. I did take some time to actually relax and give myself some rest, which I'm not that great at doing. So I'm giving myself a pat on the shoulder for doing that. Gotta give yourself a little break every once in a while. Last episode, we had the launch hangout for the Crew 1 demo, for the Crew 1 flights, the first operational flight for not only NASA's return to sending our own astronauts into space, to the International Space Station with American-made rockets. It was also a big moment for the SpaceX team, their Crew Dragon spacecraft performing extremely well, looking extremely clean while it's docked up on the ISS. Our astronauts made it there. They had a great Thanksgiving meal. There were some great photos that came out from the astronauts. They're having a lot of fun up there, and I'm looking forward to see the science that they're doing up there. We're going to have a link in this week's episode if you want to learn more about that. That was one of our questions from last week. Later in this episode, we're going to talk about the latest Falcon 9 launch, the history that booster, Falcon 9 B1049, its 7th time flying. 5 years ago, 10 years ago, it was literally an impossibility that rockets could be flown and be successful and have value in the space industry to be reusable. Obviously, those walls are breaking down. Progress is happening. We're going to talk about that. One of the questions was how much does each cost and how much are people actually saving? We did some research. We'll talk about that. But I want to start this week's episode with a reminder that redundancies and being safe and putting stuff in place, whether it's the way that the world is today with COVID and making sure you have a good behavior, we've talked about that before. If you're new to the podcast, I did come down with COVID. I did share my experience. I'm much better now. I shared my experience in one of the previous episodes. If you want to check that out, it's called Testing Positive. In case you don't have anyone that's had it, you don't have any experience, and you're just looking for anecdotal, hey, what happened? What did you do? What did it feel like? What were the challenges I dealt with? That's there if you want it. So obviously, our minds are all focused on safety in that regard. But for me, you know, we run a 3D printing lab here with Today in Space. It's something I'm also very passionate about. The lab is called AG3D. 3D printing in space are really my two passions. They give me the energy to want to do this stuff every day and to push farther and to learn more. And you know, I found out through this podcast, the 6 years of this podcast, and now the 4 years of AG3D, of our own 3D printing lab, bringing ideas into reality with 3D printing. You know, this is a crazy landmark for us. And you know, one of the good things that happened for us is that our business is basically direct to you, direct to customer, or direct to anybody, really. We can do 3D printing for almost anyone. Our website, ag3d-printing.com, people will come to us, we'll help them, whether it's literally like a something drawn on a napkin, or if there's, you know, someone who's an actual manufacturing place, a company that usually has 3D printers and they're down and they need some extra work, we do work for them. You know, we just had our friends at SnapCaller who successfully funded their Kickstarter, which is a huge congratulations to them. I'm so happy for them. SnapCaller came to us early on in the design because they were trying to figure out how are we going to make this happen, how are we going to make this work, and we helped them create a few prototypes to push their idea further, to make it real so that they could do testing and figure out, hey, do we like this design, do we not like this design? You can learn more about them in a previous episode that we did with them. You can listen to both Jack and Mike, who are the creators, and we talked about why 3D printing was important for them. So if you want, go check that out. But with 3D printing, you know, it's we make it look easy over at AG3D Printing, especially on Instagram. We're showing you all the best stuff. But one of the things we showed you recently was we almost had a fire. And I think some people who have looked into 3D printing have seen kind of those home fires. And we were very lucky that when we did have a failure, that the 3D printer that we were using, the Prusa i3 Mark, well, it was a Mark II. We've upgraded to the 2.5S. Prusa Research's printer has a redundancy, a safety built in to help prevent those kinds of scenarios from happening, from awful things, right? So 3D printing, we're printing at 240 degrees Celsius, which is extremely hot. Like basically, you're printing at the higher end of what your kitchen stove can do in your kitchen, right? So extremely hot. If any of that stuff touches something that is ignitable for a short period of time, a fire can happen very, very easily. And our 3D printers get a lot of use. We're always striving to be printing 24/7, and we have multiple printers. And we had this situation where, and we're going to show the image here on YouTube if you want to check that out, our YouTube channel. If you want to watch these episodes, obviously we're here for listening pleasure on any of these podcasting apps that you like, Spotify, Apple Podcasts, but I'm rambling here. I'm very, very blessed that I went with a company like Prusa Research that put this thermal runaway redundancy into the printer. And basically what it looks for, to simplify it, the printer looks to see if it's being told you need to heat the nozzle at 240 degrees Celsius to get the plastic to move through and print properly. If for whatever reason the thermostat, the thing that's reading the temperature, shows that the temperature is dropping and it gets to a certain point, but the heater is still giving out heat, it's going to kill the electricity, it's going to kill the print, because that's the scenario where something is broken. And that's what they've put into place to save you. Now, did I have to restart the print? Yeah. Did I have to spend some extra money, put more cost into that specific job to get the print to work? Yes, but that redundancy literally saved my house. It saved my life. So I am super excited. I'm all amped up about it this week. The first few days, what I was thinking was I was really down on myself because I was like, man, how did I let my printer kind of get to this point? It gets a lot of use, and I don't necessarily have something in place to say, hey, after 100 days, which is what? That's like 2,400 hours of printing. After 2,400 hours of printing, maybe I should replace the plastic parts that are close to the heat, the 3D printed parts that are around the nozzle, because that's what happened. Those plastic parts broke, and basically what happened was the printer was no longer able to stay at the same height. The nozzle dropped, it hit something, the plastic broke, and so this is going to happen. This is now I'm going to make myself better, and I've learned from my mistake. And we talk about the space industry, and we talked about a lot in the early days, especially about the space shuttle, because that was kind of the last era of where NASA was. And with the space shuttle, the kind of thing that killed it were not these redundancies. There were plenty of redundancies in place to basically anytime something bad would happen, they would put even more redundancies in place to make sure that, hey, if for whatever reason a system goes down, there's multiple other systems that can kick back on to make sure that the astronauts and everyone on board and the space shuttle itself are safe. The things that happened to the space shuttle were things that were done outside of the regular procedure. And I'm building. I was a very young punk talking about the space industry and talking about the past and being frustrated about how slow progress was happening with space, and especially with NASA, especially here in the U.S., and frustration for years about when will we ever get back to the point where we're really pushing the bounds of space, and anyone could potentially have the possibility to go into space and explore more and learn more. It's very frustrating about how slow we were going. Now we've got SpaceX, and they're doing crazy things like the Crew 1 launch, and not only doing wild things to set records, but doing them with NASA working with them, having teamwork. I think it was 2018 we started the year talking about, will they ever find a way to work together, and if they did, that would be the best case scenario for all of us. And they have. We're in an amazing place. And so it's funny that life is giving me a lesson again in just why things were done the way they were done, even though I may not have understood it as a younger engineer for NASA, and space flight and sending humans into space. Redundancies are very important because they help us not have to think about the things that could go wrong if we put a plan in place to prevent the things that you can control, right? There's with how I would expect Prusa with their 3D printer. Again, I'm not paid by them. I just use their stuff. I really like their stuff, and I'm giving them a lot of credit because they did save my livelihood, my life with that thermal runaway thing. They said, how can we prevent these things? Because there were stories all over the place about people's 3D printers lighting on fire. I'm talking about this too much, but my point is, redundancies are important, whether they're for 3D printing fires, whether they're for keeping human beings safe when they're launching into space, or if they're habits that you put in place on a daily basis to make sure that you don't get caught in a situation like, let's say you have to go outside, let's say you have to work in today's world, and you have to go out into public. You've got to assume that there's other people out there that are not going to have the same risk assessment as you are. They're not going to. So what can you do? With COVID, it's a complete change of how we do everything, right? So getting good habits in place early are super, super important. Having a mask with you everywhere, having a second mask maybe in the car. So if you do go somewhere and, you were in a rush that day, you forgot your mask, you got one in the car, Things like that I think are super important. And I'm just very, very happy that I was saved this week by a redundancy. Giving my younger self a kick in the ass for giving NASA such a hard time with the space shuttle and the way that they develop things. But nonetheless, we're here. We're in this new era with the Falcon 9 and with SpaceX and reusability. And they just got their 7th flown Falcon 9. Now that is just insanity. If you really break down and think about what that means for a change in the space industry and a change at the way we look at going to space from this, hey, expendable rocket, we're going to spend hundreds of millions of dollars per flight. Yeah, we're going to have a great payload ability. We're going to be able to bring really heavy things into orbit, but at a higher cost, at a very high cost that was so routine that nobody thought it could be done any different. And SpaceX spent years and years pushing this. I was researching today. Elon has said, and again, take a lot of this stuff. A lot we're going to talk about in a second here is stuff I've researched, and none of it is 100% true. It's taken from bits from interviews where Elon said something and different prices that have released. These numbers are speculative. They're the best numbers we have, so I just want to say that up front. And now that we can have this conversation. This new era that the Falcon 9 and SpaceX has brought us to is changing the whole way, and a lot of the stuff they're doing, it's working. The profit they're making from these rockets, even though they're cheaper than what the industry can offer, and they're funding things like Starlink and like Starship, where they're developing kind of their next steps. They're funding it with this reusability mindset. So it's this beautiful combination of science and business that's bringing value to not only the customers, but to the business itself. And this didn't come cheap. And this is where I want to talk about the speculation. According to Elon Musk, it cost $1 billion to develop reusability. That in itself is a huge reason why NASA could just never be able to develop that and do that on their own, because their budget is so limited. And there's so many different things that demand money from that budget. There's no way that NASA could have done that in the amount of time they did it for as little as $1 billion. So that to me is wild. But what's even crazier, and talking about this financial model that Elon has set up with SpaceX, per launch, it's cheaper for a customer, and they want to lower that price and pass on this price saving to their customer, but they need to start paying off the billions of dollars that Elon put a bunch of his money into, almost all of it at a certain point. I think at the very beginning, right before their first successful Falcon 1 launch, I think Elon had literally dumped everything. If I remember the book, Elon Musk, the biography by Ashley Vance, yeah, he put all his money into that third launch. It could have all gone away, and then all the money they've spent on it since. So it was very expensive to make things reusable, and it took a company like SpaceX to do it in as short a time as they did. Now, as time has gone on, and there's been, I've got 2 articles for you where a lot of this research comes from. One of them is how much does it cost to launch a reused Falcon 9 and why reusability is worth it. It's really detailed, especially into the math behind it. There was some research done to see some tweets that went back and forth, like from Elon and also from the United Launch Alliance, of them going back and forth talking about, giving us kind of insight into what the space industry, what it costs, right? I'm going to look at that tweet right now. So the United Launch Alliance had said that, and this is back in August of this year, that you need to refly a booster 10 times for the economics of reusability to make sense. And up until recently, with this 1049 Falcon 9, they had only done 6. Elon said that the payload reduction due to reusability of booster and fairing is less than 40%, meaning that the amount of weight that you can send to orbit is lower because of reusability, and it drops it by a little less than 40% of the total mass that you can send to orbit. And that's mostly because you've got to keep fuel on board to do those landing burns and recover the Falcon 9, which means you have less fuel to deliver stuff into orbit, which makes sense, right? There's a trade-off. That's science, right? That's physics, right? You're not just going to get it perfect every single time. And refurb of the rocket after it comes back down is about 10%. And he's saying from the math, even with 2 flights per Falcon 9, you can still recover the cost. And definitely with 3, which means that according to Elon's model, if that's actually working for them, that means most of these Falcon 9s are money-making Falcon 9s. They're actually helping them pay for this new thing, bring in more revenue so they can put it towards Starlink and towards Starship, and we're seeing that. I mean, they're doing it, right? They're paying for it. So SpaceX's Falcon 9, if you're going to fly on the first brand new Falcon 9, $62 million for a customer, apparently, to come and purchase a launch. That may seem like a lot, but you're looking at hundreds of millions of dollars with these high-end, fully expendable rockets, right? The rockets that spend every single bit of that fuel to deliver something into orbit. Yes, they have amazing capabilities. They can get you into tremendous orbits, even with other things like sending you around to different planets and having the ability to have this flexible delta V of how much energy do you want to put this thing into orbit with. And that's great. But for the day-to-day, the delivering satellites into orbit and around Earth and routine missions, especially with the Space Force kicking off, with Air Force having more and more to do, more research satellites going up for things like weather and reading the level of the ocean rising and temperatures of and there's even a lot of other satellites now that are predicting, they're gathering data on agriculture and yields in certain areas and tracking, dry seasons, wet seasons, so that the people on Earth in those areas can better adapt to the environment around them and have data when they're going to have a good season. Put more in there when they're going to have a drier season. Maybe don't plan as much and plan for that. Plan for the fact that you may have a shortage. You don't want to spend more money on a bunch of crop if you're going to have a bigger loss of it, right? So all these amazing things that have been limited because someone like the United Launch Alliance, which is a great company, great rocket technology, but they're only having about 10 launches a year. SpaceX has had at least 10 this year. So, and they've almost launched 10 Starlink satellites in this year, which missions in this year, which is absolutely crazy. So they're offering these rockets brand new at $62 million, and a reused flight is apparently at $50 million. With the first rocket, you've got about $15 million to $28 million in cost just in the rocket itself, right? When that rocket comes back in, that Falcon 9, you're looking at about $1 million to refurbish it and get it reflown. And then you're going to have to build that boost, that second stage that's on top of the first stage that gets recovered. The rocket on that top that delivers the satellite after that Falcon 9 goes off and does the rest of the mission, that's never going to come back. They're saying, nope, you got to pay for that every time. So that's $10 million for that. You've got $5 million for the fairings, which they're working on recovering, right? That second rocket, they've got $35 million on that next launch. They're making $12 million on a brand new rocket, and they're making basically $35 million on a reused rocket. So this 7-time Falcon 9 has made them, let's look at this, right? 70, 140, and another $222 million. If that's what it is, if the $35 million for their reused flight, that's a lot of money that they're pulling in. And I've heard the hardest thing they're having is the soot on the actual engines and the turbines. So the fuel that is burning and leaving behind soot. That's the hardest part. And that's why they're still not bringing in more money. The Starship, apparently, it's totally different fuel, and there's so little soot that they barely don't even have to clean them from their initial views, right? So they're already adapting what they're learning from the Falcon 9. They're in practice making this Starship easier to refurbish, which means they're going to pull in even more money. This is a totally different world that we're living in. I was even looking back at the work that went into refurbishing the space shuttle. The space shuttle, again, we talked about redundancies. The space shuttle was the first real reusable attempt, right? And it did some great things. They could reuse it, but there was so much demand on not only high-tech processes that the whole space shuttle had to go through to get cleaned and refurbished and retuned to refly. It also required a ton of people to do so. And there's this picture of the room that they used to use to get the space shuttles back up and running. And it looks wild. I mean, it must have been so exciting to do that. And I can see why so many people were in so much love with the space shuttle, especially if you talk to the people that worked on it. But it just didn't. It was the first attempt, right? So the first real attempt at reusability, especially at something like that, it's not going to be perfect. SpaceX has kind of looked at how do we make this work, and it looks, apparently by the numbers, absolutely feasible to make this happen. I want to dive more into this, but the question from last week, the whole reason I brought this up, the question from last week was, how much are people saving by using a reused rocket? And so, as a customer, right, a $62 million flight into orbit for a brand new Falcon 9 is already, by industry standard, for a standard orbit and decent delivery into orbit. $62 million is cheap. It's competitive. Let's put it that way. Cheap's the wrong word. It's competitive. Then you also have the ability to save $12 million if you go on a reused flight. So the price that was already competitive is now uber competitive, and they're showing the industry that not only are they shooting for that 10 Falcon 9 launch per Falcon 9, Elon apparently thinks there is no limit, and they could potentially do 100+ reflights with a single Falcon 9, which would be insane, but it's so good that then you have to wonder, okay, where's the law of diminishing returns here, right? Where is the point with the amount of effort that we have to do to refly these all those times instead of just making a new one, right? Where is the line? And they'll find it. I guarantee you they'll find it. They'll figure out when the line is. From what I've heard from Gwynne Shotwell and what I've read, apparently they're looking for every Falcon 9, especially these Block 5 variants, to go on average 10 every flight. So we may see some with 14 if there's any issues. There's been some that have exploded beforehand or not lasted as long. We've seen a few of those cases, but they're at 7, and I'm really excited to see we saw so much in 2020 that I am going to be amazed to see what happens in 2021, to see how much further progress happens. And one of the things I'm super excited for progress-wise in space is obviously Starship. So SN8, we talked about this on Instagram. I don't know, we've been promoting the SN8 hop, the 15-kilometer hop, for a while here. They attempted it, but they had a disk burst, which is actually a redundancy, right? So one of the things we saw with the Starships, they got the hop right. They did Starhopper, right? They did SN6, which delivered the mass payload, and it did its hop. Now we're actually getting the first Mark I Starship. This is an older model. It doesn't have these. It's basically looks like this with you're going to have the fairing on top, and you're going to have the side flaps here, and you're also going to have the ones on the top there, and those, it's going to perform the belly flop coming back in. So SN8, they had another chance. The burst disk, the redundancy they put in, which was this burst disk, prevented what had been happening where when they fueled these rockets, something happened with the pressure, and the thing exploded. Now, if we're going to send humans, obviously that's no good, and it was definitely a little concerning there for a while, wondering how are they going to fix this. We saw with the first attempt at SN8 that this burst disk is going to relieve the pressure and as the word says, burst before the fuel tank does. So that is amazing to have that redundancy in place and to see that they're already thinking about the next step of how do we get this to go. It obviously saves them money too, not having to build any more starships than they already have. So they actually had a chance to retest it, put new Raptor engines on SN8, and it looks like this week, because there could be delays down in Boca Chica, they're going to be trying to do this 15-kilometer hop. 15 kilometers is not, it doesn't seem like it's that tall. Like, you think 15 kilometers, like, what is that? How do I have a reference for what 15 kilometers is? So I did look up some things, some numbers, right? I actually did a little research, so I'm going to talk about the different things that are 15 kilometers. We're going to go through them now, and that's how we'll close this week's episode. How tall is 15 kilometers? 15 kilometers is about 45 Nimitz-class aircraft carriers, where if you had the aircraft carrier on the ocean and you went perpendicular to the ocean, basically had it standing up the long way, you would have 45 of those stacked tall. It's also 39.4 Empire State Buildings tall. It's 5.5 Golden State Bridges tall if you stack them, if you, again, went perpendicular and laid them all the long way. It's 214 Falcon 9s tall, 135.5 Saturn V's tall, 403.5 space shuttles. It's also 5 Borg cubes tall, 665 AT-ATs tall, 93.5 vehicle assembly buildings, and that's the one we went to when we had our visit in December for our NASA social. That's the building where they built the space shuttle and assembled the Saturn V. This is the building that has assembled the greatest rocketry of all time, and it's huge, especially if you go and see it. It's 93.5 of those tall, is 15 kilometers. But I think the most relatable thing is, the typical cruising altitude that you reach when you're actually flying in the air, going across the country, around the world, wherever you're going. Cruising altitude, it's 1.3 times the typical altitude that you reach when you're flying on a commercial airliner. And just think about if you've been on a plane and you've looked down and you've seen that view, add 30%. That thing is going up, doing a maneuver to basically belly flop itself back down and test that re-entry, basically from launching up, belly flop, using the air and the flaps to control its return back, just like we've seen with the grid fins on the Falcon 9, right? You need control when you're coming back in. And then it's going to do this flip where it has the bottom of the rocket, where the thrusters are, where the engines are, to relight so that it can control its momentum as it comes back down and lands softly. That's what we're looking for with SN8. We'll also get multiple attempts at with SN9 and SN10 with very similar, some upgrades, things that they've learned from SN8, doing testing, prototyping, and adding what you're learning, and just moving quickly, making progress and learning along the way. That's what SpaceX is showing us. And that's what I'm super excited for in 2021. We're going to talk about more of this as December rolls around and as we get more episodes out. But just wanted to share some of that stuff with you this week. Thank you for joining us. We've got some really interesting interviews with some interesting people. We'll have some people of science before the end of the year. We'll also have some episodes where we just put a bunch of stuff together, give you the best of what 2020 has brought us, because there hasn't been a lot of great, but we've got some great moments from the podcast. We've met a lot of great people and really expanded our community here on Today in Space and the people that we're talking to. and I'm really, really looking forward to more of that here in the future. So thank you for joining us today. I'm Alex Orfanos, your space podcast host from the East Coast. Be well, spread love, spread science, and we'll talk to you next time. And don't forget, you can always send us your questions, whether it's on Instagram at Today in Space Pod, that's on Twitter at Today in Space Pod, and you can find me at El Greco, ELGR3CO. You can always email us at todayinspace podcast at gmail.com. That's it, folks. Be well. See you next time. Hello, everyone. Welcome to the podcast. Many intergalactic greetings to you, my friends.